morning, everyone. Thank you for coming. To start with, who here is at least somewhat familiar with addressables? Maybe you've pulled it down, you've played with it, okay? And who here is kind of coming in blind, not really sure what we're talking about? All right. One more, who here has played with or used asset bundles in the past? Okay, a lot of you. So for context, for anyone that really has no idea what we're talking about, this is all about content management. Addressables, asset bundles, these all deal with how are you going to build your content, how are you going to load your content in your game. So let me tell you a quick story. A few years ago, I learned to ski, downhill snow skiing. And it's a lot of fun, I really enjoy it. But on day one, what you learn is you take your skis and you point them in like this. And they might call that the wedge or the snowplow or pizza if you're a kid. But with your skis like this, you kind of just lean down the hill and off you go. And that works really well at first. And then one day you're up on top of the mountain doing a real run, and you realize that that skill doesn't really translate very well. You've got to learn a new set of skills and a new set of techniques to manage your way down the mountain. So why do I tell you this? Well, at times, learning Unity can be like that, where the thing you learn on day one that seems straightforward, perhaps even obvious, doesn't necessarily translate to being up on top of that mountain, working on a real game with a large team at scale, supporting a released product. Content management is a really good example of that. On day one, you have scenes. You put everything in the scene. Everything's a direct reference. When you load the scene, everything's in memory, and everything's probably local. And then one day you're up on top of that mountain, and you realize that that doesn't scale. And so you've got to learn things like asset bundles. And how are you going to deal with dependency resolution? How are you going to manage your memory? And how in the world are you going to update content for a game that you've already released? My name is Bill Ramsour. Today I'm going to talk to you about how the Addressable Asset System can help you manage your content when you've got a real live game out in the world. Now I will point out, it says Unity Live Content Team. I did want to mention, essentially this is a team that we formed from the build pipeline team as well as some others, to try to give you guys an end-to-end solution on content management. So addressables is a piece of all the things we're working on. So what are we going to talk about? Well, first I'm going to give an overview of addressables. This should be enough for those of you that are brand new to give you the context needed to get through the demos. And for those of you that are already familiar with addressables, some of this will be repeated information, but some of it will be new because we have a UI refresh coming out. In addition, after the overview, I'm going to go into 3 demos. Now, all of these demos are on GitHub, and I have the link there. We have actually several demos on GitHub, with several sample demos there. I'm going through 3 of them because they show some specific attributes and functionalities that I want to highlight. The first one is sprite loading. But that demo is really about showing the concept of working with sub-objects. The second one is texture quality variation. And that's really about how to customize your build. And the third one is about synchronous addressables, which, spoiler alert, addressables are asynchronous. Talk more about that in a little bit. But this demo is how to build a synchronous wrapper around that. But it's actually about how to customize your runtime. And then at the end, I'll have a what's next. And I don't think I'll have time for Q&A at the end, but afterwards, I will be immediately outside this auditorium, available to chat for anybody that wants to talk, and then I'll be around tomorrow at the live content booth. So why addressables? What's the problem we're trying to solve? Well, there's 3 key pieces to that. Building your content, managing it at runtime, and iterating during development. For building your content, without addressables, everything's very coupled. How things are built, what their file path is, how they're loaded, where they are, that's all very tied together. With addressables, we aim to decouple that and simplify the build process. For the runtime, we deal with dependency resolution. We figure out the dependencies for you. We also deal with memory management. When you load something, we do ref counting to make sure that if 2 different things are sharing the same asset, that it's in memory when it needs to be, and it's not unloaded out from under somebody. And then lastly, iteration. It's complicated to get in and out of play mode when you have a very complicated content management solution. We provide several mechanisms to make this easier. And in addition to that, if you're dealing with hosting, things get even more complicated, and we've provided a local editor host within Addressables, within the editor itself, that I'll talk more about later. But the real why is actually best summed up with a quote from the folks over at Jam City. They're working on an unannounced title, shipping later this year, and the essence of the message is that they got into games to work on games, not to write complex content management solutions. And that's probably why most of you got into it, to work on games. So we want to solve the content management problem for you so that you can focus on your game and make your game more fun. So what is Addressables? Well, to explore that, I think it's best to walk through the flow of data within Addressables. So if we start up here in the upper right, you're in the editor. You have an asset, and you give it an address. That now is an addressable asset. You've given it the address tree. So when we build, we're going to build that. We're going to generate the content needed. Now that content, by default, is asset bundles. We build asset bundles under the hood. But it'd be easy to extend it if you needed raw files, if you needed some other format. And we also build a bunch of data that we consume. And then at the runtime, what happens is the app comes in and it says, I need a tree. Load tree or instantiate tree. And that request comes in, and it goes first through our content catalog system. And that system is what decodes that address tree into a location. And the location is the data that we've generated during the build about what the asset is, what its dependencies are, where things are, if things are local or remote, or all that information. It's all decoded in the catalog. And then from the catalog, we go through to the provider system. And here, probably more than one provider takes those locations and provides you the content. So it goes to the catalog, through the provider, gets you the content, and returns it to the device. Now, that content could be anywhere. It could be local, it could be up on a server, it could be generated. So one of the constraints of Addressables right now, as I mentioned earlier, is that the runtime is asynchronous. This gives us the flexibility to have an app that just says, I need tree, and I don't care where it is. You can have it early in development, maybe that's on your device. And later, your app gets too big, you have to set up a server, that tree's up on some server out in the world somewhere. The game code doesn't have to change, the game code doesn't have to care. It can just say, load tree. Now that we have this context, I want to speak a little bit about some of the previous Unites, what we covered there, and what we're going to cover today. So Unite Berlin a year ago, that was the first talk on Addressables. That was sort of a lot of the basic concepts, a lot of working in the editor, a lot of getting things set up. Then, also in 2018, was Unite LA. And that covered a lot of the basics, but then it also focused, the main focus, the meat of that talk, was on content update. How do you update your content for a released live game? Today, I'm going to cover a lot of the basics, a lot of the introduction, but then the focus of the talk, the meat of the talk, will be on customization. Customizing your build and customizing your runtime. And you'll notice that my box only goes around the provider, because at the runtime, that's the piece of code. That's the logical bit that you can customize easily. And there's one other thing that's different between this talk and the previous ones, and that's that we're out of preview. We shipped in June, removed the preview tag. We're going to be verified in 2019-3, supporting back to 2018 LTS. And Where Cards Fall was actually able to ship using Addressables last week on Apple Arcade. So we're really happy for them. It's a great game. Really happy that they were able to use our system and got some success out of it. So a couple of concepts I want to get into before I get into the demo. Groups. When you mark something as addressable, it is in an addressable group. Everything's in a group. All a group is it's a container that knows what addressable assets are in it, and it knows some data. There's no logic on it. It's just data. And so the build script runs through every single group and says, tell me about your assets, tell me about your data, and I'll figure out what to do. You can visualize these groups in our groups window. This is sort of the home base for addressables, the launching pad, if you will. You can look through each group, see what assets are in it. You can drag things around to different groups. You can rearrange things. Now, if I look at one of my groups here, let's call it Space Shooter Data. I've got an asset in it, say, with the name Starfield. So that's its address. And that one also happens to have a label of preload. So that means I can access this thing, loading it by the address Starfield or the label preload. And my game code won't actually care what group it's in. If I make it move to a different group in this window, the game code doesn't care. And the group is important for a lot of reasons. It can affect how things are built in a lot of ways. But the biggest one is whether or not that asset is going to be local to device or up on some server. And again, I just move it from one group to another. The game code doesn't care. It just works itself out. Now, if I select one of these, I've selected DLC1 here, and I've got my inspector, so we can see what the data is. So the data on groups is held in what we call schemas. Those schemas are basically data contracts. So if I look at one of them here, this one's called content update restriction. Now, we used to just actually have this be a checkbox that said static, but in the UI refresh that's coming out, we've made it a little more verbose because that's probably more helpful. But this one is all about how to update your content post-release. And that's, again, what the Unite LA talk focuses on. And all those previous talks, by the way, are on YouTube, available to watch. But the schema I want to really highlight is the one that focuses on how your assets and your content is going to get built into bundles. And there's a lot of advanced settings here. I've collapsed them. But the main settings that you're going to mess with the most are the build path and the load path. That is what determines, obviously, where it builds and where it loads from. And that's how you figure out if something's going to be local or remote, is you set those settings. Now, you'll notice that that's not a field you type into. You don't type in a path to that field. It's actually a variable you select from a dropdown. Now, just below it, it does say what it's going to evaluate to, but you're actually picking a variable. And the reason is we have a system we call our profile system. And in that system, you create a profile, you create some variables, and then you define for a given profile, here is what I want that variable to evaluate to. And that gives you the ability to set your data on your group and then be able to kind of change it remotely without having to touch the group. So let me walk through an example of what I mean by that. So this is how I want to ship my game. And I always say that with addressables, you want to visualize your data the way it's going to ship, not the way you're developing it. You can use the scripts and the systems to change things to be more convenient to develop, but kind of visualize them how you're going to ship. Now, you're not locked into anything. You don't have to plan it all up front and be like, have complete perfect foresight of what's going to be local and what's remote. It's easy to change things. But start thinking about how things are going to be set up. So here in my game, I've got some local content that's going to be in my player, and I've got some remote content that's going to be up on a server. So this is the profile I'm using. I've got this production profile, and it's set up to have some things be in streaming assets, and that's what this variable is. It's a little weird, complicated variable, but that's just our dynamic evaluation of where a streaming asset is. And then I've got one that's set up to be hosted on myinternet.com, which is a really good URL I've nabbed. And it's great. This is how I'm going to ship my game. But it's a pain to develop this way. You wouldn't want to actually set up the server for development. So this is where profiles come in. I can create another profile that I've called local, and I just set the remote paths to point to streaming assets as well. And so now, without touching my groups, I might have 100 groups. I might have 2 groups. But without having to touch the groups, I can globally change all of my remote content to become local. And now, when I'm in development, this gives me a concise player to use. If I need to ship a build off to a publisher, I can give them one concise thing. But sometimes you do need to play with having a server and having things connected. And that's where our editor hosting comes in. I can set up my remote path. Instead of pointing to my actual URL, I have it set up to some variables that our hosting service defines. And what this does is the hosting service, when enabled, can set up an HTTP host within the editor that my device or my player or my play mode can connect to. And this way, I'm sort of mimicking reality and able to test things out. But taking this step one step further, what if I put everything remote in my editor hosting? This is actually an incredibly powerful feature, especially for content developers. So let's say I'm an artist. I come in, I build the player, I build my content, and then I deploy the player to some device. Now that deploy was pretty quick because the player itself has no content. It's just the DLLs, it's just some basic scenes. It's pretty lightweight and small. So I've deployed that to the player. Then I launch it, I open it up, it'll connect to my editor, it'll download the content that I need at that time, and I can look at it and say, you know what, that tree needs to be more purple. So I come back to the editor and I purple it up a little bit, then I rebuild my content, and then I just relaunch the player. And it'll connect to the editor, see that there's a new catalog, that the catalog has been updated, so it'll download that. And then when I ask for tree, it'll say, oh, I know where tree is, it's up here. There's a new one, I need to download it. And that'll just happen. And so as the artist, I deployed a device once, and then I can iterate on my content over and over without ever having to deal with that deployment, without having to move content from one device to another. It just works. Now, these are the kinds of workflows we've been working on. We really want to make sure that these workflows are ideal for you guys. We've actually been working closely with the folks over at Romero Games. They've been using addressables since the very early days and given us lots of feedback on the workflows. We're really excited to see Empire of Sin and what they're able to do, and really happy with their work with us and the support we've been able to give them and the support they've given us. So with that, I'm going to jump over here into the editor. All right, so I've got Unity up here. And I've got a scene with 7 sprites in it. I'm going to show you 7 different ways in addressables to swap out the sprite. So I grab the sprite renderer, I'm going to load some sprite from memory, and then assign it. So how do I load something in addressables? Well, there's 2 main ways. The first way is by its address. If I come over to this Addressable Groups window, which we talked about as kind of the home base, you'll see that I've got a thing I've called sheet, which is a sprite sheet. It's just got a bunch of frames in it, and then a sprite atlas, which I've named atlas. So those are the addresses, and I can load that by saying load asset async sheet or atlas. Now, you are going to be loading by string probably a lot, but a lot of times it'll either be a generated string or maybe driven by data. But when you have an artist workflow, that doesn't work very well. If the coder is working in code, setting up the strings, the artist is working in the editor, loading things by string isn't the best workflow. So the other way to do it is what we call an asset reference. So if I jump to the code real quick, I have, in this mono behavior, 5 asset references. And what these are weak references. So they feel in the editor kind of like a direct reference. To the artist, they can just set it up and hook it up so that this asset reference is pointing at this asset. But when you load this scene, these aren't going to be loaded into memory. They're loaded when you ask them to. And now you'll notice that most of them just say asset reference, but one is asset reference atlas. And that's because the asset reference itself is type agnostic. You can load and reference any type through an asset reference. Generally, you're not actually going to want to do that. This code here is not ideal. You're going to want to constrain those asset references. And here, the third one, I have constrained to only be able to reference a sprite atlas. So if I come back to the editor here, I can select this controller, which has my 5 asset references. And you'll notice if I click the drop down here for the unconstrained one, it's got the same list of assets that my groups do. If I come to the constrained one, it only shows the atlas. Now, I'm going to show you different ways to do this, to load sprites. And the first one I want to show is actually not through an atlas or through a multi-frame sprite sheet. I just want to use a basic, simple, single sheet. And so I have a sprite down here I've named single sprite, very descriptive, and it's not addressable yet, but I can grab it and drag it up here, and you'll notice if I try to drop it on the atlas constrained reference, it won't let me. But if I come up here to the top one, I can drop it on there, and at this point, it is now addressable. It has an address. And that defaults to being the file name. I'm going to change it to something more descriptive like line, because it's sort of like a line. If I come back here to the controller, you can see that there. Now you'll also notice that this split in two. And that's because the asset reference recognized that this type supports sub-objects. Now I'm not going to use that at this point. I will use it later. But if I go here and I were to switch this back to, say, the scene, you'll notice it's not split anymore because there is no sub-object you can load from a scene. So if I come back to line, it's there. And because I don't want the sub-object, I want the main asset, I'm just going to leave this as none. So let's jump back over to the code here. And if I come down to the loading code, you can see I've got my asset reference. And I say load asset async, again, everything's asynchronous. And I tell it the type, because this is an unconstrained asset reference. It doesn't know what type it needs, so I have to tell it sprite. And then I'm just going to get back an operation. It's actually an operation handle, but I called it op1. And you'll notice I go ahead and kick off all 7 of my async operations, and then I'm going to come down here and wait for the first one to finish. And once it's done, I'm going to set that in the sprite renderer. That part's pretty standard Unity code. But the thing I want to highlight here is this wait. You can yield return on one of these ops. You can async await, or you can set a completed callback. You have the flexibility in how you want to know that it's done. In addition, the way I've set up this code so that it does these in sequence once they're all working is I put a delay in here between each one. And so by the time I get to the second op, they're actually probably all finished. And so I'm choosing to just yield return on through all of these. But you can actually ask the op if it's done. There's a lot of mechanisms there. So if we come over here, let's make sure that my line actually subs in here. And I get a little bendy line. Perfect. So come back here, and now I want to do the sub-objects, but again, I'm not going to do it through the asset reference yet. So I'm going to pick my sprite sheet, which is a multi-frame sheet, and my sprite atlas. And again, I'm not going to pick the sub-objects here because I first want to show it to you in code and then through the asset reference. So I come back to the code here. And this second one, which is my sprite sheet, I'm actually loading, instead of with the type sprite, I'm loading it with the type iList of sprites. And what that does is it tells addressables that you actually want a list of every sub-object of that type. And so here you're actually going to get this list of sprites back, and I think I index into it. I get the 5th one out. And I just can get this whole list of sprites and pick the one I want. And then the next line, to show you what the atlas one looks like, you'll notice I don't tell it a type. That's because this asset reference is constrained, so it already knows it's a sprite atlas. It already knows what type it needs to do. And then here, again, I interact with it the same way you would interact with any sprite atlas. I think I say get sprite is the interface. Yeah, get sprite and the name. So let's make sure we get some little squiggles and dots, like I'm hoping. I'm going to get a line and some dots. Cool. So now let's do the last ones. So I'm going to pick sheet again and atlas again. But this time, I'm going to actually pick the sub-object I want. So let's say 1 and 5. And if I go over to the code, because I've specified exactly which sub-object I want, I can load that just as the type sprite. And so then the code down below where I'm taking that result looks exactly the same as the first one, because I'm loading a sprite and I get it back. Now, while we're here, I want to hit on these last two, because these last two are not set up in the editor. I mentioned that you can load things by address, by string, but what if you want the sub-object? Well, this is the syntax. You take the address, and you give brackets, and you give it the name of the sub-object you want. And this might be a little complicated to just type in, but we tell you what those available addresses are. So if I come back to the editor, I can take this sheet here, and I can expand it, and it'll show me what all the sub-objects are. It'll tell me what the address is of each one and how to load it, the exact syntax. Similarly, in this atlas, I can see the same thing. So now I've got, on my controller, all my asset references hooked up, and the last two are by string. So let's see if I can sub out all 7 of my sprites. Lines, squiggle, dots, and then a few more sprites. And it worked. All right, look at that. So, thanks. Before moving on from this sprite demo, I wanted to jump over here to this groups window real quick. As I talked about, this is sort of the launching pad or home base for addressables. And a lot of interactions are going to be done here in this tools menu. This is pretty much everything you'd want to do in addressables you can do here. I talked about the profile system earlier. The window for editing it is here. I wanted to mention our analyzer. This is a system that runs rules. And we've given you several rules, but it's also easy to extend it to create your own rules. And they run, and some of the rules can even fix themselves. So an example is one of the rules we've provided is a duplicate asset check. When you're building asset bundles, it's very easy to create a situation where assets are actually getting duplicated, and sometimes you want that, but a lot of times you don't. So we have a rule here that can search your data, figure out where things are going to be duplicated, and then you can actually just click fix it, and it'll unduplicate it for you. There's also the hosting service and several other functionalities in here. So I'm going to jump back over to PowerPoint briefly to talk about the next demo. Customizing the build. So I've added a little bit to this slide here, which is those 2 statements there. When we build, there's 2 reasons we build. Either because you have told us to, by telling us to build your player content, or because you've entered play mode. So we run a build script in either scenario. Generally, those are going to be different scripts. The scripts themselves can define, hey, I am a script that works for building content or entering play mode or both. With addressables, we provide 4 scripts. One of them for building player content, and that's what actually builds all the stuff, all the data, all the asset bundles, everything. And then 3 for going into play mode. Now, of the 3, the middle one, which sort of simulates bundle layout, will probably rarely be used. It's only specifically for doing some profiling. We have an event viewer window that keeps up with our ref counts, and that's useful for that. But most of the time, you'll either be using our fastest, which is the asset database load. And what that'll do is when you enter play mode, that builds the catalog, but it doesn't build any content because it's going to load the content directly from your project. And that gives you the ability to, while you're iterating on content, get in and out of play mode without actually having to build asset bundles and build your content. And the third one, use existing build, actually doesn't do anything when you go into play mode other than some error checking, because it assumes that all this stuff's already built, and it's going to use the real data. It's going to use your real catalog, your real asset bundles, all of that going into play mode. So if, say, you're the programmer and you're not messing with your content, that's actually probably the easiest way to do play mode because it doesn't really do anything when you go in and out of play mode. So let me jump back here to Unity. So here I have a cube with a texture on it. And it's not the real texture. That's why there's a big red X in it, so that you know don't use this texture for realsies. But what I'm going to do is I want to set up my game so that when this thing is loaded, I can dynamically either replace it with the high-definition version of the texture I want, or the low-res version of the texture I want, depending on my device's capabilities. So the way I'm going to be doing that is this project only has the main high-res version. And during the addressables build, I'm actually going to generate low-res versions and include them in the build. But before I get into the custom build piece, I want to jump over to the runtime code to show you what that looks like. So here is this addressables load, just like I was doing in the sprite demo where I was loading by string. It's the same call. This time I'm loading a texture instead of a sprite. But the key difference here is in the sprite demo, I passed in a single string. And in this one, I'm actually passing in this keys variable, which is a list of strings. And what that's going to do is we've provided a mechanism for passing in lists of things, and you can tell us, I want everything that touches anywhere on this list, or in this case, I've said I want the intersection of these. So I want any asset that has all of these keys. And if I look at where I'm calling my helper function here, in one place I'm calling tree SD and another tree HD. And what I'm saying is I want something with both the address tree and the label HD. And I will note, things can have addresses and labels. At runtime, they're actually the same. We can't really tell the difference. If you say load tree or you say load HD, it's just a key that we load from. So here in my project, I'm expecting to have two different assets with the same address. They'll both have the address of tree, which is totally legal. You can give things the same address. And one of them will have a label HD, one will have a label SD. And I wanted to focus on the runtime piece first, because in our case, for this demo, we're going to generate these on the fly. But there's going to be many times you're going to want to do something like this manually. Say instead of HD and SD, that was English and Japanese. You could do localization through this sort of mechanism. And oftentimes, you're probably going to have a helper function that instead of taking two keys, you would probably give it one key, and then have the helper function call into some global system to say, what's my language right now? Or what's my device's capabilities right now? That sort of thing. So let me get back over here to the editor and talk about the build. So to create a custom build, as we talked earlier, the build loops through every group and says, give me your entries and give me your data. And so generally, when you're creating a custom build, you're going to want custom data. So if I look at a plain Jane group here, it has the same two schemas that I showed in the screenshot earlier. It's got the one for building bundles and the one for doing an update. But if I pick the one that holds my tree, I've got a new schema. So this is just a schema I defined in my project. And again, this is just data. And the data is what I've called a baseline label. And then I've got an array of pairs. And each pair has a scale and a label. And so that's my custom data. And my custom build script is going to loop through this. And it's going to say, for each group, it's going to say, do you have this schema? If you do, I want to loop through all the assets, grab every texture. If I see a texture in there, I'm going to apply the baseline label to it. And then I'm going to copy that texture. For each entry in this array, I'm going to copy it, scale it, and apply a label to the scaled version. And then at the end, the build script cleans itself up. So this build script can actually be run on the project. It'll generate all the textures. It'll put them all in the asset bundles. All the content's ready to go. And then it deletes the unnecessary artifacts. So if I look briefly at the code here, this script that I've made actually inherits from our main bundle building script. And so my script doesn't have to build bundles. It doesn't have to set up the content catalog. All it's doing is this texture duplication. And so I've overridden the process group function to check for my schema. And then I've also overridden the main entry point so that I can do my cleanup. But I've commented out the cleanup. Now, again, the reason that I have code in here that I'm not actually running today is because this is just taken from the sample online. It's in the GitHub sample online for us. So I'm going to turn off cleanup, because if it cleans itself up, you can't really see what it does. I'm going to come in here and go to Build, New Build, and you'll notice this one is the one that we ship with. This is the one that I've added. So I'm going to click this Build here. It's going to think about some things. And now what it did, you can see it applied the label HD to my main texture, created 2 new groups, MD and SD, and there's textures in each one that are scaled down. If I look at this guy, it's 512. This guy is 32 by 32. Now, I actually made 2 build scripts for this demo, and I want to talk about why. So one here is the one I just showed you. And oops, cancel, click the wrong thing, slow down. New build, this is the one I was showing you. This is what we just ran. But I also made a script for going into play mode. Now, if I've built my data, and I've run this custom build script to actually build the real content, then when I go into play mode, I can do the basic use existing build script that we ship. Because all my content's in there, it's valid, it's ready to go. But in fast mode, that's not really the case. In this faster asset database mode, if I come in here and revert everything back to the way it was with no labels, and I just use this basic use asset database call, then the catalog it's going to generate, because like I said, this first script, when you enter play mode, generates a new catalog based on the current data. It's only going to know about tree, and it's not going to see anything with a label. So I've created a custom script here that's actually pretty lightweight. All it's going to do is, similar to the other build script, it loops through. If it finds the custom schema, it's going to take all these textures, but this script is built for quick iteration. So I don't want it to be generating a bunch of textures and doing all that kind of work. So it actually comes in and just says label, 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 and then it's done. And so this is another way to get things to work. So now my code works. Every tree is going to look the same. The high res and the low res version will all be the source asset, but that's fine for this quick iteration mode. And with that, I'm going to jump back over here to the presentation and go through the synchronous demo. Now, the synchronous, I'm actually going to stay in PowerPoint because it's just really explaining some concepts. There's not that much to see in the editor. So for this demo, what it does is it builds a wrapper around addressables that provides synchronous interfaces through addressables. So to think through that, first let's look at what would a synchronous addressables look like if it was in its native form. Well, we'd have some synchronous API you could call into, and then it would have to make sure everything's ready. Do we have a catalog? Is our system initialized? If not, you're kind of sad, because we need to be able to download a catalog. We need to do some things asynchronously on startup. But let's assume everything's initialized, and then it would somehow do some sort of synchronous call, whatever it is it needs to do, and that would either succeed or fail, again, making you happy or sad. Now, this could fail for the normal reasons. Corrupted data, files not there, that sort of thing. But it could also fail because you're trying to do something synchronously that can't be done synchronously. Maybe it's a download. You just can't download synchronously. So there's some constraints around this system. So now let's look at the demo itself. Since it's a wrapper around addressables, the first 2 steps are actually the same. The wrapper, you call into the wrapper, it checks to make sure everything's ready, it cries if they aren't ready. But then, instead of calling a synchronous function, it actually calls into addressables through the asynchronous API. And then when it gets the operation back, it immediately checks, is this operation done? If so, we're happy, and if not, we're sad. Now, how do I call an async function in addressables and get back a completed operation? Well, let's look at where the operation comes from. The app calls into the catalog system, it does some decoding, it sends the locations to the providers. The provider kicks off anything asynchronous it needs to do. This is in the normal standard addressables. Kicks off anything asynchronous it needs to do, and then the provider returns that op handle. And so that's why for this demo especially, but really for almost all runtime customization, the customization is in the provider. And what we're able to do is have the provider do what it needs to do synchronously, complete, and then return an operation that's already done. So how do you make sure that the right providers are doing that? How do you get a provider that can complete synchronously and return a completed operation. Well, earlier I showed you a screenshot of the schema that we provide on how bundles are built. I had collapsed the advanced settings, and now I've expanded them. And you notice at the bottom, you get to specify the provider, because we know that's a key customization point, so we've exposed that from the get-go. And so in this case, I've set it to sync asset provider and sync bundle provider. And the reason there's two is all of our data is built into asset bundles. And so one provider provides the bundle itself, downloads it or loads it or whatever it needs to do. And then another provider loads the asset, the specific single asset, out of that bundle. And the code is actually fairly straightforward if you're allowing yourself to be very constrained. Here's a snippet from the synchronous asset bundle provider. Really all it does is it loads the file because it insists that it's a local file. It does an error check to make sure the load worked, and then it returns a completed operation. And it's as straightforward as that. Now there's some more code in this file, and the synchronous loading an asset from an asset bundle code is a little more complicated. But generally, the concept stands that a provider can do some synchronous behavior, handle things, and return a completed operation. And so with that overview of customizing build and customizing the runtime, I did want to give one bonus mention, which is data encryption. A lot of people have asked about how do we encrypt bundles? How do we encrypt our data? Well, if you take the two last demos I just talked about, customizing your build and customizing your runtime, you can now have encrypted bundles. In the build, you could set up a schema that maybe had a encryption key or maybe had some encryption information in it, and then a custom build script that would just run the base one and then take those results and encrypt those bundles. And then you just have a provider that when it loads the bundle, it decrypts it. So it'd be fairly straightforward. We're actually working on a sample that we'll be adding to that samples repo soon with this, because it is something that's been requested a lot. And so before I get into the what's next, I've got one more customer quote from a very excited customer. This is Disruptor Beam. They've been working with asset bundles for a long time, and they've been using addressables on a new product that's unannounced and will be shipping in 2020. We're very excited to work with them and excited to see what comes out of that. So what's next? Stability and bug fixes in the current addressables. I've got the UI refresh coming out that we talked about. We've also got, we're exploring synchronous interfaces, and we've got a few other features we're working on. Also in 2020, we'll have addressables plus dots shipping. And I also want to tease a content delivery service. As I mentioned, we've got this live production team. Addressables is a piece of that, but we're working on an end-to-end solution. And eventually that end-to-end solution will include hosting. Now, this content delivery service could be used without addressables, or addressables could be used without it. But if you use them together, they'll play really nicely and gives you an easy workflow to start in the editor, work with addressables, have your content hosted, and it just all seamlessly plays together. So to wrap things up, here's a couple web links, the GitHub samples, also the forums. I cannot speak highly enough of our community. I really appreciate all the people that have been on the forums answering questions. I try to be very active there, so if you guys have questions, it's a great place to ask them. Also, we're out of preview, supporting back to 2018 LTS. We've got a webinar that we worked on this summer that should be on YouTube soon, maybe before this talk is, I'm not sure, but probably within the next month. That should be online under Unity's account. And then after this talk, I'll be immediately outside that auditorium, available for questions. And then if you think of something while you're lying in bed tonight, tomorrow morning I will be at the live content booth in the expo hall from 9 a.m. to 11. So that's it. Thank you, everybody. Have a great Unite.